Hi, my name is Frank Piller, and I'm very much looking forward to this webinar together with you. We want to discuss, is your business model ready for Industry 4.0? I will lead you through some of the frameworks I also cover in the master class I have with the Leadership Network called Leading the Factory of the Future. And we'll introduce you into the framework we have after some introductions, and then go into some of the key questions with regard to business model innovation and Industry 4.0. And at the very end, I also will outline a practical approach we developed in our research here in Aachen to really cope with this. So, well, you may have seen my profile on the internet. I'm Professor of Technology and Innovation Management here in Aachen University, Germany's largest engineering school. And I'm really interested more or less in the things I will talk about in a minute. Also, I've been involved in quite some companies to really test in practice what I somehow discover in our research. Aachen, as I said, we'll consider ourselves as a leading university of technology, and actually every second engineer in the German automotive industry with a university degree still comes from Aachen. But much better than going into these details, let me tell you a typical story of innovation from Aachen, and that really shows you not of something we are proud of, but really what is possible today because of digitalization and Industry 4.0. So if you're living in Germany, there's a very high likelihood that you see this delivery car. It's an electric delivery car by DHL to do the parcel services and the normal mail services within a city. It's produced by the so-called Street Scooter company, a spin-off of our university, and which now is a 100% subsidiary of DHL. And the really amazing thing is that this car was developed in just 3 years for less than 30 million budgets. And this 30 million included the entire factory and regulation and street certification and so on. And that DHL, who since several years wanted to have an electric delivery vehicle, went to their leading manufacturer of their nowadays cars, big German car companies starting with V, and they gave them a quote that this will take probably 8 years, and say it will charge them more than $500 million, as this is a niche vehicle and it comes with very high cost. So why is a university able to develop something and bring it to street within 3 years for 30 million, where the established players say we need 8 years and more than $500 million? And actually, the real development time was even shorter, as when the team started to go into this, they were already 1 year spending on in a city car, which they then somehow changed into this delivery car in actually just 2 years until the first working prototype was on the street. So is it magic? Well, not really. On the first thing, it's a typical capability of a good German university of technology, and this is to organize and facilitate and manage large open value networks of different partners. It's actually what is behind the magic of the street scooter is not that everything was developed here from the scratch, but really assembled and combined in a very clever way. So it's this ability to really manage a big network of shareholders and, of course, across digital innovation. And this brings me now a little bit closer into what we are seeing today. What follows a couple of slides by WZL, the institute that was really the core player in developing the street scooter. So traditionally, what we have in many companies is we have a strong division in separated departments. We have mechanics, electronics, software design, and all are involved in the new product development process, but also later on in the manufacturing of this product. And we have an increasing interdisciplinarity in development projects, and we all praise interdisciplinarity and diversity, and we know we need it, but of course this leads to a lot of conflicts. On the one hand side, semantic conflicts on when people from different backgrounds have to talk to each other, and on the other conflicts on the, let's say, IT system level with regard to data consistencies and information losses. Old stories if you work for a large company. And so, and I don't go much into this today, we really talk a lot about T-shaped competence profiles, that we need people in our development teams that are able to think in the system and that have a broader understanding of the entire picture, and then really a deep dive of a domain-specific know-how. And the same somehow, but just vice versa, is happening on the right-hand side of my previous picture with regard to data consistency. So what we have nowadays in most companies is actually a very data-rich environment. We have lots of data, often too much data, but this is in very different silos. With CAD data, simulation data, process data, machine data, later perhaps feedback data while we are in the field, from service, from customers, or test data from agencies and regulators and so on. But somehow we want, and this is one of the big promises of Industry 4.0, and what's also technically now easier than it was in the past, is to integrate this data in something that we may call smart data. And to really bring this forward, we have to work on that. It's just another picture on what I just said before. So we have the big two problems of inconsistency in data and connection between different systems, and at the same time that the usage of different systems requires expert knowledge. So what the street scooter team did, they really created and spent a lot of emphasis in setting up a unifying PLM system that really could unify all the different data that was available in the development process from all the different sources. And this is the one piece what's happening, but we'll come and I'll explain it in a second with some other slides in more detail. We have another vision which is really happening. As traditionally we had our data really with regard to development, and then in automotive we call it a ramp up, we pushed the development into the manufacturing floor, ramped up manufacturing, and then went into operations. And of course there also were silos of data, and from time to time perhaps they were synchronized and matched with each other. But what they do for the street scooter project is very, very deeply not just look, really is connecting these two data sources and using what is happening in production and assembly and even in usage in a unified picture to have an holistic picture. We later will call it the digital shadow, one of the core concepts of Industry 4.0 and also one of the core enablers of new business models. So what they really achieved in the street scooter is to have a picture of the development cycle, the production cycle, but also the usage cycle, and integrate this and have a single source of truth in utilizing this data. So that now, after the product is out in the market for now a little bit more than 2 years, there is a big change request or a new version coming up, you immediately can see, simulate, and really execute how this change request will have implications either production or development. So here's the car we are very proud of, and it even goes better as the same teams of a company, DHL, went back and got the money and built a new car. And what they just have launched is a Germany-built electric car for 12,000 euros retail price. Looks actually quite nice. And the marvelous story here is that they also developed a very scalable car factory for 30 million. It was opened, we are very recent with this webinar, actually last Friday here in Aachen. It does not look like a McDonald's fast food restaurant, but it's more or less the same concept, that you have a scalable, replicable factory that has an output of 30,000 cars a year. And if you need more output, you just put another factory next to it And again, for a price tag of just 30 millions. And why is this possible? Because of digitalization. Here you see a few pictures from inside the factory, digitalization, robotics, and advancement that even make manufacturing of cars much cheaper and more efficient as we always used to have it in the past. And just for the recording, we have some voice in the recording. Whoever has not muted their microphone, please mute your microphone. And so this is the Ego car that is now going around here in Aachen in the first trials. So why these introductions? As these are examples of what is really possible today. And it's not just because of the advancements of IT, but actually we have to thank these two guys, and always like to thank them at the beginning of my presentations, Win Kerf and Bob Kahn, the inventors of, well, yes, the TCP protocol, not really the internet, but the basic communication protocol. And in my opinion, it are really the advancements of we have with regard to communications, enabling higher degrees of connectivities and collaboration, what is driving all the excitement around digitalization in Industry 4.0 today. So it's really the networking ability, our enabling a higher productivity of collaboration, which is at the core of Industry 4.0. So this slide by SAP AG, I think, is quite meaningful, where they said what we call the fourth industrial revolution is not one of digitalization or computerization. That was the third industrial revolution, but of networking and connecting things and people and assets and so on. So let me now spend a couple of minutes in introducing our smart industry, smart factory framework. And this is a very demanding task, as I normally need at least one day to explain this in detail as part of a 3-day masterclass. So for the full picture, come to my masterclass, but here's the brief one. So the idea is that we have an underlying technological infrastructures of a lot of new technologies that are coming forward today, and you've heard of many of them. And as a first pillar in that model, we have the smart asset dimensions. And here, two elements: smart equipment and the so-called already mentioned digital twin and digital shadow. So when we talk about Industry 4.0 and what's happening on the shop floor nowadays, we often refer to so-called cyber physical systems, perhaps without taking this proper technical term. But the idea is that we have a physical existing object that has sensors, provides us some imaging, some data, process data, models, topologies of what is happening with it. We store it mostly in a cloud, and then we have a layer of services, which we often nowadays refer to, not totally correctly, but a little bit getting the idea, as algorithms. And those together are the building block of what makes most of Industry 4.0. And if you are in a shop floor, this is actually not too novel for you. So most of your assets already have sensors and you already collect a lot of data. However, in most instances, you don't really utilize this data on a routine basis beyond security checks and alerts, but not really for decision making. And this is enabled by the digital twin or digital shadow. This is a term that comes up more and more, and for me it was always difficult to understand it. So what's the difference to traditional MES data? What's the difference to a traditional simulation model of our asset in the factory? And the following example helped me a lot. So where we are here, and I'll come back to this model later on in the presentation, what we have here, if we start in the lower left, we somehow make, measure, and connect. This is where we have our cyber physical systems. They provide a digital image, a digital shadow, or the digital twin, which we later on use for decision makers, either prescriptions or predictions. I'll come back to this, which help us then to analyze and predict our physical world and optimize there. The idea, going to the lower right, is to really have an adaptive real-time optimization of our systems. And it all starts with the digital twin or digital shadow that's really is starting gathered in the cyber-physical system. So the example that helped me to really understand it was that of Google Maps. Well, of course, you all use Google Maps, and you know it. And Google Map is like a perfect digital twin. It's a really good image of the reality, much better than a traditional map, more up to date with much more and dense information. And then it gives you this digital shadow of the utilization of the road, the live traffic information. And this actually is not really real-time data, but like in Germany, Vodafone provides every 5 minutes an image of the German cell phones to Google to provide the traffic load of our road system. So the idea of the digital shadow is that this is what is really happening in your assets, while the digital twin is really a replication of the assets. Here we can be very precise, but even with today's data processing abilities on the data level, we still have to reduce it to have meaningful things. But the combination of the digital twin and digital shadow is really now what makes this interesting. So why is Google Maps so much better than your old map? Well, it gives you this predictive traffic information. This is how much I probably will need 5 days later today, 5 hours later today to the airport. Then it can give us dynamic suggestion for alternative routings. It can tell us, well, there is a bottleneck, go there. It even gives us alternative means of transportation. And probably Google knows better than the city of Aachen where to build a new highway to continuously avoid bottlenecks. And this is really where Industry 4.0 starts, with the replication of the digital twin, but it's actually the digital shadow that allows us this additional applications. But then, if you know something about navigation systems, there's a new one called Waze, which actually is even better than Google traffic, as it's not just all machines, but they use human knowledge and human expertise to even build outsmart traffic together, as it said there, and their drivers report potholes, speed traps, and so on. So with Waze, we have a combination of a digital twin, a digital shadow, and human expert knowledge. And for me, this is a perfect picture of what is happening in many other domains as well. So if you go back to this picture I had earlier to explain the street scooter success and the data model that was behind it, that was exactly what they enable, to have a single source of truth. They call it a PLM system. You may call it your smart data warehouse. So the first pillar were these smart assets with data. The second is now smart operations. So what we do with this data. On the one hand side, going back to that earlier quiz picture, it's now really about utilizing the data for, well, the following slide is a little bit a litmus test. Where are you with your Industry 4.0 journey? As I would say, if we start here on the left, that most of you are able really to realize when something, let's say we have unplanned machine downtime, and then you are able to access what really happened and why did this machine break. Well, probably you also moved then to stage 2 and said we not just realized, oh, this machine broke as motor X in this machine was overheating, but you realized then perhaps, oh, that motor was overheating as there was this load profile on the motor, and then at this time, because of that load profile, the motor was overheating and the machine stopped. So if you're able to do this pattern recognition, well, then you're at level 3, forecasting ability, what's often called predictive maintenance in that kind. If we now know that this pattern was responsible for breaking the motor, now we can just observe our assets in real time, see if the pattern is building again. And we see that the pattern is building again, well, then we can predict that the motor will break again in, let's say, a week, and we already order the spare part, the famous case of predictive maintenance. But actually, it's totally, well, not bullshit, but it's not enough, as if we know already that the pattern is building and that the motor will break in a week. Why do we let it break? Why do we not change the load on the system, change our production schedule, and really make different decisions? That would be now the prescriptive analytics. And this is really where, for me, Industry 4.0 starts, that we have decision ability, what can be done to make it happen. Either ordering the motor or spare part in good enough time in advance to don't have downtime, or change the load, or even in the future change the design of the machine, will put in a larger motor that does not really is so error prone, and so on. So along these 4 stages, you can count for yourself. Where are you on your journey? What are you able on it? Is it 1, 2, 3, or 4.0? And this demands new jobs. So from a brochure at Siemens, I found this wonderful new job titles. What they have: operational data interpreters, digital environment maintainers, and so on. And these are exactly people responsible for enabling what I just presented. And there we are already very much on the level of the smart worker. The third pillar now is with regard to smart supply chains. So in smart operations, we really stay within one focal factory. In smart supply chains, we go into connecting factories, managing a network of factories, and also the underlying logistics and supply chain activities. I don't have any time to go into this, but if you remember my example earlier from the Ego, the small blue electric vehicles you saw, it was a 30 million car factory. This is exactly what they have, the vision that all these factories obviously are connected, that you really know what is happening. And if you do local optimization in one of these factories, well, this knowledge is somehow automatically downloaded to the other factories to always being on one state of the art and expertise. And the fourth one is where now we'll spend a little bit more time, as now we come to the heart of our talk, business model innovation, is a solution ecosystem. As the idea is, and this is one of the strongest ideas, that whatever you do it collaboratively. And if you're a larger company, that can mean this connectivity of your own factories, but it also can mean the connectivity with your partners and all your network activities. So the real question around here, and this is where I would like to start with, is what new business model can we enable with our smart factory? And why is this important? As you know, if you're a manager, that you manage something, how you think about it. How we perceive our world is how we shape our decisions. And in Industry 4.0, I see 2 big patterns when I talk to executives, when I visit companies and ask about the digital strategy for the factory. On the one hand side, on the left-hand side, is an evolution model, the exploitation model. And I have to admit, as a German, it's a very German model. It's really a focus on technology-enabled efficiency gains, the digital enhancement of products and services. It's digitalization of the data flows in manufacturing. It's empowerment of human decision makers and operators. And in the end, it means we do exactly what we always did, but now digital and more efficient. On the other hand side, is a disruption or exploration model where they say, well, let's utilize all the new technical abilities we have to not just make a better factory of today, but really build a new factory for tomorrow. It's a radical reinterpretation of the value proposition. It's really putting the factory in the center of the business model, saying now we have these new kind of abilities. What new kind of business model can we enable for our corporation? It's very much about digital products and services that are part of an open ecosystem. We'll have examples about this in a second. And coming to open manufacturing concepts, sometimes also cloud-based manufacturing. So therefore, to complete this picture, on top of these pillars, smart assets, smart operations, supply chain, and the solution ecosystem, we always have to ask ourselves, what kind of business models are we enabling, and what is the business model, why we are doing it? Coming in the orange part from the left, are we really looking on industrial efficiency drivers, operational efficiency, and so on, which is totally great, a little bit boring on the long term, and perhaps not leading you far enough, or are coming in the blue from the right side, are we really talking about differentiation, individualization, agility, really using our factory to enable a new business model? Let's explore the right side a little bit more in detail. With a recent case from Germany, and it's one of those companies that is really considered in all instances one of the big digital champions, even if it's from a very, very traditional industry, agriculture. Class, well, is a small kind of John Deere if you're from the US. Class is an agricultural company, very well positioned on the market. And actually, agricultural equipment was one of the assets that were turned into smart products, cyber-physical systems, quite early. Why? Well, you utilize some of these assets only for a couple of weeks in the year, but in that time, you really want to have them 24/7, and you don't want to have any unplanned downtime. So this was an industry where products were becoming smart products with sensors, predictive maintenance, and they also became connected to clouds, connected perhaps to even weather data, and so on. And then if I'm a company like Klaas, I realize, well, from the perspective of my farmers, they don't want to have a tractor platform and a combined harvester platform and a planter platform and in addition a tiller platform. No, they want a unified farm equipment system where a farmer can manage all of his equipment on a digital platform. See the connectivities to really optimize operational efficiencies and minimize unplanned downtime. And that was the perspective of most of the agricultural companies. And they spent millions and millions to build these farm equipment systems, also bridging across different companies. However, if you're a farmer, your picture looks very differently. If you're a farmer, this farm equipment system is just one small piece of the game. You also are interested in a system that really provides the weather data. You are interested in the irrigation system, all the water management. And especially nowadays, you're really interested in seed optimization and crop protection. This is why Bayer acquired Monsanto. This is where a lot of experts see really the future of agriculture. But somehow all these systems are connected. And as a farmer, you want a farm management system, not just a farm equipment system. So sounds logical. But now consider you as a top manager at Klaas. As now really your strategic question is, where are we in that game? Should we continue to do a farm equipment system? And this already is pretty brave, as this is integrating beyond our core products. Or should we go to become a farm management system, also integrate all the other data sources and value drivers to manage a modern farm? And of course, intuitively, if you're a family-owned company like Klaas, you would say, let's stay with farm equipment, as actually managing weather and seed and water is not our business. But then you start thinking, saying, well, actually, wait a minute. If we let someone else doing it, in the end, our tractors just become an expensive asset to collect data. And all the value from additional services is not enabled by us, but someone else. So in the end, a tractor just becomes an expensive commodity and we are getting commoditized. And where is the future of our business? And this was really the crucial question for Klaas. On which level should we get engaged? Should we become really this platform provider, or shall we join an existing platform? And obviously, as you know from you being a consumer on consumer platforms, in the end, it's not a winner takes all market, but almost there will be 2 or 3 winners that really divide the share of digital farming. So class really, and this is why it's a nice case, said we go forward. We really create an open platform they call 365 FarmNet, totally changing their business model from becoming an asset provider of very high-end German engineered farm equipment to become a farm management platform that is not just integrated other providers of equipment, but also like their crop protection and seeds, Allianz, farm insurance, and so on. And they realized we really have to be open here, and this means also open for competitors, open for like John Deere, a 10 times larger company that is allowed to go on the platform, see the machine data of class, optimize on that. But well, what do you want to do if you have a farmer that has both John Deere and class? Well, the farmer will not accept that they can't bring the asset on it. So it was a very brave and tough decision, and the stakes are still on. It's a low and conservative market, what is happening, but it's a nice story. And then from talking to class, I know a lot of strategic questions have to be answered in your business model decisions around this. So how can we really capture the value we have created? And related to this, what is the optimal level of openness? This is one of the crucial questions. And I urge you really to think about this in your company. As we talked a lot, and if I talk to listen to other presentations, we talk a lot about value creation through Industry 4.0 connectivity, digitalization. We have a lot of nice business models. But in the end, it's not about creating value. If you're a company, it's about capturing the value. And here, this optimal level of openness is important. So I told you, class on their platform, let's go back one slide, they were very open, and this is what we are preaching to them. However, if you're too open, well, then it may happen, real case, that there's a cool Silicon Valley startup that realizes, oh, there are these Germans, they built a nice farm management software, all open data, let's just access all this data, go to the farmers, say, well, thank you, you gathered all the data, it's very nice, but we give you exactly the same services, 50% discount to what you are paying today. Well, and then as class, I realized, well, probably I shouldn't have been too open. But as I said earlier, if they would not have been open, probably the platform would have not developed. So I can't give you a real answer on it, but just want to sensitize you about it, that this probably is one of your core strategic decisions, thinking a little about what's the optimal level of openness. How can we build network effects, attract others to our platforms? How is this influencing the borders of our firm and industry? But also related to this, can a great hardware design become a competitive advantage in a platform-based industry? I strongly believe yes. We talked a lot in the past about digital services and assets, and this is where everyone is talking about. But, well, I think most of you still live in a physical world, and most of you still provide physical assets and physical goods, and also want to consume physical goods and want to utilize physical assets. So there still is a lot about hardware. And one of the strategies class is really doing is that they say we're really good in engineering, we are expensive, but as good as we were in the engineering of our performance, functional performance attributes, you know, what farm equipment does, perhaps we have to become as good in the quality of our sensors, in the connectivity of our sensors, in the holistic picture our sensors do, but also in the agility of the actors, you know, to translate the sensor information into efficiency of effectiveness drivers and so on. So also really believe that good hardware design can become a competitive advantage in a platform-based industry. But overall, the ultimate question for a class here is, like for every company, what is really the core of our company? What is it? Why we are existing? And then if you think the story further, how much should class really become an IT company, and how much are they an agricultural equipment company? And as I said, I believe this is exactly your question. And this is a question that's being asked by managers in many, many industries, as almost all goods and assets are somehow being platformed in the moment. And this rise of platforms is one of the core economic paradigms we observe today, and also, I would say, the core underlying drivers of business models for Industry 4.0. And if you go back to the Leadership Network site, you find a small article by me with this picture in more detail and explanation that we not just have these decisions to be made from companies, should they become a platform, but also for those of you that just have to want to join a platform. And again, it's probably not a winner, but a couple of guys will take it all market, and there are so many alternative models, more or less selling you all the same, at least promising you the same. And theoretically, we understand platforms market quite well. There are a couple of Nobel Prizes in economics, the latest for Jean Tirole, on really understanding these two-sided platforms. But what we know in theory may be not sufficient to really answer the questions I raised before in practice. So in our own research, we strive to really understand these business ecosystems a little bit better. And again, I only can cover this very, very briefly here, and we'll have more time for that in the masterclass. But the platform on the lower end has really an infrastructure on the technical level. It has a value creation layer. These are the apps, the algorithms that really do the prescriptions and predictions. Then we have a value appropriation layer. We really capture what we have. In the end, your revenue model, your cost model, your pricing model. And then lately, but really perhaps most important, a governance layer here shown in the red on the highest level, where we really define the rules of the game, where we define the openness of the platform, who is able to access which kind of information, and so on. And around this, a very interesting observation was happening in the German machinery industry in the moment. There was another company exactly with the same questions as Klaas, in this kind HOMAG. They are in the niche, a world market player. They do wood processing equipment, equipment you need in a furniture factory and so on. And they had exactly the same question. Our equipment is getting smart. Our customers, the furniture manufacturers, are creating smart factories. They want to share the data from their machines on a higher level platform that provides some functionality, provides the data management, perhaps also enables me to compare my factory and my assets with similar companies to learn from their errors and experiences. And so they were asking themselves, well, should we join one of the big platforms like SAP MindSpheres, SAP, Microsoft, and so on, GE Predix, or shall we build our own platform? As if we join MindSphere, GE, whatever, perhaps in the end, again, we are just commoditized, we just provide the equipment and all the value capture is done on the platform level by Siemens, GE, and so on. And they started to build their own platform, which they coined Tapio, with very cool graphics and machine boards and so on to really have access to the data, can optimize the machines, have idea about maintenance and so on, but faced exactly the same questions as before. And when they asked themselves, what is the core of our company? They said, different than Klaas. No, the core of our company is to make the world's best wood processing equipment, but not to really build an industrial data platform. And this is why they joined a cooperative of other companies with exactly the same questions that say, let's build a platform of platforms. And it's called Adamos. It's getting a lot of traction and attention in Germany in the moment. And here at the lower left, you see HOMAG, and you see a couple of other big companies like Zeiss, Dürr, DMG Mori, all companies facing exactly the same challenges as HOMAG. And they all wanted to have a digital platform And for this, you need a platform infrastructure, you need machine learning capability, analytics capability, device management, security data story, and so on. And what they said is, let's really do a company together, as the Street Scooter Consortium was initiated at the very beginning of my presentation. Let's put all a couple of million euros in a big pot. We hire a company, a software company called Software AG in this case. They build us a platform which we co-own, which we can govern, but it's not the core of our business. It's something like an infrastructure, but an infrastructure we really can manage. And then facing our customers, we all have our own app stores. You know, Homag, it's Tapio stores, it's Size app stores, and so on. So towards the customers, we somehow have our unique profile. Towards the back end, we have a white label solution called Adamos we can utilize all. So it's too early to say if this will succeed. But I really like the initiative, and it also shows the experimentation and agility companies need to have today to really answer this crucial question on business model innovation. What is it really, what our business model is, and what is the place in the business model of our entire industry we want to take? So just follow this Adamos initiative. Perhaps you're even working for one of the companies. As I said, I don't know if they will succeed. It's a very ambitious task, but really interesting of taking your own destiny somehow back in your hand, but doing it as a cooperative. This is exactly what we'll try to work on and understand better in our research. And so let me close my talk with a small methodology how to really build platform-based business models. And you get my contact data at the end of this talk, and I'm happy to share some more information about this. As a challenge for you and all our companies now is that the more you go away from operational excellence to new business models, the more you have to make decisions not based on knowledge, but you have to make decisions based on assumptions. Assumptions about openness, assumptions about future industry borders, assumptions about value captures, assumptions about a lot of things you really don't have realistic data on yet today. So the core of business model innovation is actually methodology to build and test better assumptions on your business model. And therefore, the first part are so-called canvas models. And if you know a little bit about business model innovation, you may know the business model canvas by Alex Osterwalder, shown on the upper right. The famous business model canvas, it's a wonderful tool, and there's plenty of web information about this business model canvas. However, it is really built for a focal company. And we realized when working with companies, it's not really well suited to map an ecosystem. So we came up with a platform business model canvas, which is a very small and reduced piece, just your value propositions, the skills you need, but then focusing on your docking requirements and the system stability. And then the idea is really not just to map you, but also the other partners in the ecosystem in getting a more holistic pictures with whom you have to connect and also from whom you can get services on that. So the second element beyond this canvas, which we somehow use this business model canvas, the first element, to really outline an assumption, different prototypes of how our business model could be composed. But to make it a little bit more systematically, we use platform design factors, well, PDFs, or so-called business model patterns. And the basic idea actually is that all business models in the end are composed around repeating patterns. And we tried, building on the picture I explained earlier on the 4 layers of a pattern, to really extract building blocks of successful companies that really showed us some building blocks, not of an entire business model, but for example, on the level of governance, on the level of value appropriation, on the level of value creation. Here are just a few. Condition monitoring is one of the big examples applied. It's like a value creation mechanism behind a lot of digital business models, that you sell the service of really monitoring the condition, or you use it to enable other business models. Well, you even can have a sensor as a service, where you somehow equip your equipment with sensors, but only when you really need this information, you pay for it. You can move to guaranteed availability if you now have sensor as a service. You combine it with condition monitoring algorithm, then you can change your business model. Instead of selling an asset and spare parts later, in selling guaranteed availability, one of the other value creation patterns. So here you see them outlined all. We can't go into it, but perhaps you got the idea. The idea of this element is that you systematically can analyze all the alternatives you have, all the different pricing models, and not just realize what you saw at your competitor or that just comes to your head. And finally, whatever you build out of, you have to test. And the idea, and that's a third element, and I'm coming also to the close of this webinar, and I'm looking forward to your questions if you have some, so be prepared to ask some questions, please. The third element is rapid experimentation and validation of alternatives, meaning whatever we came up with our ideas, how our future business model could look like, the more we really have to be able to test the assumptions before realizing the full business model in reality. And this is actually what worked very well in our master classes on the Factory of the Future, that we spent almost the last 2 sessions of the seminar, that every participant builds some assumptions, first defines assumption, builds it, and then develops a very simple test to really validate these alternatives. And so overall, that is perhaps an idea how you could create and move forward for digital business models for Industry 4.0. You need something to really map it in its entirety. You may rely to patterns or platform design factors to spur your creativity and really get a larger solution space of what is possible. And finally, you need a tool to validate your assumptions and experiment with them to come quickly to a solution which you then may implement and practice in an agile way. So many ways to create value with Industry 4.0. And I only could really give a short introduction into this in this webinar. And all this is complex, and it's both complex on the technical side, on the business model side, on the money side, on the skills and capability side of our companies. Yes, it's not easy. This is great. Thankfully, it's not easy, as otherwise it could not become a source of competitive advantage. As all things that are easy are not competitive advantage, they are benchmarking. So it's really, and perhaps you got some ideas about the trade-offs you have to manage when really looking into Industry 4.0. It's much more than putting sensors and new data models in your company. It's really about creating a new business model. And I strongly believe that you should go beyond operational excellence in your thinking and strategizing about Industry 4.0. Yes, operational excellence is great, and it may pay the use case and convince your top management that you have to do it. But for the future of your company, operational excellence is not enough. So really ask yourself, what's the job of your smart factory? What is really the new business models you can enable? How you really position yourself in an open ecosystem? But also, of course, what do we have to address internally to enable this? And would be delighted to discuss this more in detail with you at one of our Factory of the Future masterclasses with the leadership networks. And I have to tell you, if you sign up now, you even get 20% discount. So would be really delighted to talk together. We are really, and this is why I like to teach these classes, normally a great community of people on a very high level of seniority, and normally have very good discussions about these questions I raised and many, many more. So this is where I am now. I am at the end of my webinar. Reach out to me if you have other questions, but there now is still time, 10 minutes, if there are any questions from the chat. So thank you very much for listening. Hope you got some good ideas. And Carolina, are there any questions?
Hi there. Thank you very much, Frank. Yes, we have some questions here from the audience. There's 2 questions from Muzaffar. One of them is IBM Food Chain and Mobility Blockchain Initiative are creating platforms on the blockchain technology. Do you think that the new platforms will be best all on blockchain?
Definitely not. So first of all, blockchain is a great tool and it can solve a lot of problems we have. But actually the word blockchain and platform is a little bit a paradox, as often the core idea of blockchain is that you don't need a central entity any longer, but that you can connect the assets or whatever you want to connect directly with each other as a core function of a traditional platform. This is why we call it a platform orchestrator, is to build trust and leverage between the parties. And the core idea of blockchain is to really enable this in a way where you don't have to build trust in a system, but the trust is somehow implemented in the blockchain. So my answer to this is I believe that blockchain also in industrial applications can be a very promising complementing, supplementing technology. But at the time being, and what's the recent state of technology, I don't see that it's becoming the dominant logic for most industries. So for some applications, we really want this direct connectivity of assets or actors. You may use it, but I believe strongly that in most instances, you also want to have a more holistic picture with some central control.
Thank you very much. There's also a question from Thomas. He said, we recently researched IoT platforms. BCG found less than 300. Not a single platform was what we would call mature, or at least not lacking important parts such as openness. How is your view on the current IoT platform matureness?
Yeah, great question. And I'm not a core expert on all of these platforms, but I would share the observation of Thomas. This is really an industry in its rising, and we are in an early stage with a lot of shakeups. However, I would say there are a couple of players that have proven models, and I don't want to outline some, but if I, as a German, refer to Siemens MindSphere, for example, but Predix or others of the big industrial platforms, I think they're quite at a level where they are useful. And they often can do theoretically much more than most users want to do with them for exactly these questions. That a lot of the open questions for me are not the technical questions, but are really these governance questions, what also Thomas mentioned with regard to openness. So am I really sure what will be the consequence of joining one particular platform today in, let's say, 10 years from now? How much of the data I share with the platform and then perhaps with other players will be really crucial for me in the future, that I would have had an exclusivity on that data? So yes, and I think this is exactly the challenge. In one industry group, we calculated that today, 2018, we are at less than 5% of usage of these platforms, meaning less than 5% of operational business process that by their design could be moved to a platform have been moved. However, in this group, we estimated that this will move to at around the time period of 2021 to 2024. So in 4 to 6 years, they will move from 15 to 40% of processes. And this is really the crucial window of opportunity and of action. So in the moment, I would say it's still okay to observe the market, to do pilots. And this is what most companies are doing. But I think it's now also the time to really get prepared. As if your industry is on that 40% level of business processes move to an industry platform, and you are not part of this, then it will be very, very difficult to catch up. In the moment, still everything is possible.
Thank you. Thomas actually asked for any examples if MindSphere has a major vendor lock-in.
Well, yeah, of course, as in many instances you have lock-in, and especially if you see Siemens or others where the industrial data platform is connected to hardware, in this kind Siemens automation technology. On the one hand side, this of course is a big advantage of MindSphere, that the control of your factory or assets with Siemens automation technology, where they are probably for good reasons the world market leader, is connected with the data models and the platform. But on the others, the danger of being dependent from that particular player is even larger. So I don't know a case where a company really, failed because of lock-in into this. As I said, it's much too early, but the danger is there. But it's again what I said earlier. The danger in this particular case, it's at the same time its beauty of really having a unified model with very quick execution. So as I said, and I'm sorry, I can't have a better answer, it's really managing these trade-offs. And not solving them on one to the other side, but balancing these trade-offs, which will define the value of these platforms.
Thank you. And also another question we had was, Peter Well talks in his book, What is Your Digital Business Model? About 4 different digital business models. The ultimate form he describes is the ecosystem driver. Is the ultimate goal for companies nowadays to aim to become an ecosystem driver?
Very good question. Short answer, no. As if I interpret the term ecosystem driver correctly, it means that ecosystem drivers are those that manage the platform. If this interpretation for me is correct, my answer is no, as most of all companies will not be a platform, but will be an app. In the end, a machine is an app. And most of us will be hopefully more like Angry Birds than Apple iOS, meaning just by definition, most people can't be the one that own the ecosystem or drive the ecosystem, but those that provide an important application, either on the hardware or on the software level. And I think this is exactly one of the mistakes I saw with many German companies, that somehow they all have these holy grail in front of them to become a platform orchestrator, an owner of an industrial data platform. And you can waste billions and billions of euros into this vision. And if you succeed, you have world leadership and the holy grail. But it's so likely that you will not succeed. And this is why I really urge companies also to still really understand how platforms work, really get deep knowledge, but keep into their mind that they should find a business model where they are not the driver of the ecosystem, but an important contributor to it, like an app.
Perfect. Thank you so much. I believe that's all the questions that we have. Please do note that there is a handout in the side panel with Frank's presentation that you can download, and we'll also send you the recording afterwards, as well as your discount link if you wish to book Frank's masterclass. Thank you very much, Frank. I hope the webinar was helpful for everyone. And yes, any questions, please also do feel free to email on either Frank's email or myself.
Thank you very much. Bye-bye. See you
Thank
again.
you. Bye. Bye.